All right, looking at part 2 of 13.3, our sense organ, the eye. Now let's jump right into our pupil reflex. This is going to ultimately be what our pupils are doing when we experience dim light and when we experience bright light. So the reflex action carried out to protect the retina, remember that's that back lining of the interior of your eye, from any type of damage from light that is too bright, is why our pupils are going to be incredibly small and not allow too much light in. Like, so think about when you see the brightest light, like you're coming out of your home and the sun's out and you, coffee. I'm good. All right, so brightest light coming out, it's like, man, right? We're going to squint. But also what's going on is your pupil is getting incredibly small because there's too much light that is getting to the back of your retina. The opposite is true when we face dim light. So if it's too dark in a room, what's going to happen is your pupils are going to enlarge, which means dilate or widen, in order to allow as much light as possible into the eye so you can make sense of what you are seeing. Okay, so in bright light, our pupil constricts. In dim light, it dilates. Now, we can specifically look at what is going on with each of the muscle groups that we have inside of our eye, and I will provide this for you on your notes. So just know this is something that you will have provided for you, or you can pause it right here and check it out. But looking at dim light, in a dark environment, what we are going to have going on, our radial muscles of the iris are going to contract. Circular muscles of the iris are relaxed. That allows for a dilated pupil for more light to enter the eye. When we're dealing with bright lights, so bright sunlight, someone shining a cell phone flashlight in your eye, you can even do that to a friend and kind of see how their eyes change. We're going to have the radial muscles of the iris relaxed, circular muscles contracted, and this is going to constrict the pupil to allow less light to enter. Okay? We have a nice, neat little table here, again, provided in your notes, that walk you through radial muscles versus circular muscles, what they are doing, pupil size, and then the amount of light that's entering the eye in dark light and bright light. And then we need to discuss accommodation. So what accommodation is the way that our lens brings about focusing on objects that are either really far away or really close up. So our lens is elastic, and its shape can be changed with suspensory ligaments that can tighten or loosen depending on what it is we're trying to focus on to either read or see that's far away. Now, these ciliary muscles and the suspensory ligaments, you can see suspensory ligaments right here attached to the lens and the ciliary muscles towards the top here. Now, when we're looking at an object that is near, we are going to have ciliary muscles that are contracting. Then we are going to have suspensory ligaments that are they're slackened, so they are not constricting. This allows the lens to become fatter and light is refracted more. So when we are focusing on a near object, we're going to squeeze our lens down to be fatter. So the result is light is refracted more by the lens to focus on a near object. Now, all of that being said, the opposite is true when we're trying to look at something that's really, really far away. So if we're looking at something that's in the distance, our ciliary muscles relax, the suspensory ligaments stretch very, very thin, and this allows the lens to become much thinner. Okay, and this means light is refracted less. So the result in that is allowing the eye to focus on that distant object with a thinner lens. And here's a nice table, again, that will be provided for you. This information, honestly, the best way you have to do it is just kind of learn it, memorize it. It is the hardest material that we have in this unit just because of understanding what's going on. If it's near to you, you've got your fatter lens. If it's further away, we're stretching it out. So the way that I remember it, if it's closer, think about your lens being pinched up close. And if it's far away, your lens is stretching out, trying to see far away. I hope that helps. And the only other thing we need to talk about wrapping up are just rods and cones. Remember, these are what line the retina and help us detect either darkness and shadows, dim light, bright light for our rods. So our rods are sensitive to dim light, and cones, which are what we use to distinguish between different colors in bright light. So there's 3 types of cone cells that are sensitive to different colors of light, so red, blue, and green. This is where if you have any issues with color blindness, I kind of mentioned that in the first video. And it's important to note that the fovea is an area of the retina where almost all the cone cells are found. So that's just an important note that you may be asked on a test question, where almost all cone cells found, and it's the fovea of the eye, which was found on your diagram. And then rod cells are found all over the retina. The only little snippet, another little tidbit you need to make sure you understand, is that the area where the optic nerve attaches to the retina, there's no light-sensitive cells in that area. So it's called our blind spot. And we can actually find our blind spot with a neat little activity that I can print off and we'll do in class just for fun, because you can do that. All right, so that wraps it up for this part 2 of sense organs and looking at the eye. Go ahead and head on over to your notes, get all of those down, make sure you have your tables, and you'll take your CFU, do your activities for the day. Good job, guys.